virtual STTP on optimization tools and techniques for solving real-world problems in the field of electrical engineering, which is organized by IEEE Bombay section in association with Department of Electrical Engineering of P.R. Pote Patil College of Engineering and Management in collaboration with Department of Electrical Engineering, State Vincent Pallotti College of Engineering and Technology, Nagpur. For today's session, we have with us Dr. P.P. Bedekar, sir. In the yesterday's session, sir discussed about the overview of optimization, and sir has given the wonderful examples of optimization which are very much useful in our day-to-day life. So for today's session, sir is going to deliver the presentation on overview on popular optimization tools and technique. So I request Dr. P.P. Bedekar, sir, to start the session. Please, sir.
Thank you, madam. Very good morning to one and all who have joined this course and who have joined today's session. Madam, am I audible?
Yes, sir.
PPT is also visible?
Yes, sir.
Okay, fine. Thank you. Very good morning and welcome to short-term training program on optimization tools and techniques for solving real-world problems in the field of electrical engineering, which is being organized by P.R. Pote Patil Education Welfare Trust's College of Engineering and Management, Amravati, in association with St. Vincent Pallotti College of Engineering and Technology, Nagpur. So actually, it's a nice experience to see that different colleges from different places are organizing STTP jointly. That's great, and I really appreciate the management, staff, faculty of both the colleges. This is actually the idea, work together for the betterment of society and the nation. So welcome to this STTP. And today, instead of tools and techniques, I will be focusing on one tool only, and that tool is MATLAB, in which we have many number of tools. So as the topic to be taken today, as suggested by the organizers, is tools for optimization. The most commonly used tools and the most friendly is the tool or the tools rather available for optimization in MATLAB. So today I will try to cover few tools of MATLAB optimization toolbox. I'll try to explain how to use those tools for solving our problems. As I said yesterday, that it is not necessary for a person who is working or who is doing research or who is working on a particular topic of a particular core area. Maybe that core area may be electrical engineering, chemical engineering, civil engineering, or anything else. In electrical engineering, it may be high voltage, it may be machines, it may be control system, it may be power electronics, it may be power system, or anything. So a person working in a particular area, in a particular domain, need not necessarily study the theory or even the algorithm or the procedure of different optimization methods. If you recall, yesterday I have listed I have given you a long list of optimization methods. I mean, a list of methods which can be applied for one category, linear programming problem, a long list of methods which can be applied for solving unconstrained nonlinear optimization problem, another list for available for solving constrained optimization problem. So it is very much possible that while working with a particular problem, particular area, working in a particular area, we may come across different types of optimization problem. We need not, yesterday only I have told that we need not go through the different methods. We need not spend our time in studying different methods. No need, absolutely. What we have to do and what is most important is formulating the problem. Once the problem is formulated, you have many tools available. MATLAB is one of them and is the most popular. Scilab is very much parallel to this. Scilab is also having a very strong MATLAB toolbox. Those who cannot get MATLAB, who do not have MATLAB available in their college and who have not purchased the authentic version of MATLAB, they can download Scilab. Scilab is free of cost. It is open software. And in Scilab also, we have many optimization tools available, which are very much parallel to the tools available in MATLAB. So let's take some of the tools. Let's see how to use those tools. See, when we talk about tools, it is very important to know that how to use those tools. Only having tools is not sufficient. One should know that how that tool is to be used properly to make better use of the tool. So it is just similar to the general example, which we can say that I have a welding machine and the welding rod is also available. But if I do not know how to use that, it is absolutely useless for me. I mean, I cannot do welding. अगर मुझे नहीं समझता है कि कैसा वेल्ड करना है तो I cannot use that particular tool. And similar is the case with software tools also. If you do not know how to use, then you cannot do anything with that tool. It is simply of no use. So I'll try to say focus on few of the tools today. Some of you might have used those tools. So for those who have already used the tools of MATLAB for optimization, for them, this particular session may not be of much use, or maybe a short and brief revision for them. Anyway, let's continue for optimization using MATLAB. And before proceeding for optimization using MATLAB, I would like to list few applications of optimization in power system engineering. Engineering applications of optimization specifically to power system engineering. So I am even not talking about electrical engineering as a whole. I am talking specifically about power system now. In power system, as I said, I'll be displaying few applications, just a list. We will not go into the details, just a list. And then after studying the tools of optimization, which are available in MATLAB, I would like to take a few of the examples from this list, optimization examples from this particular list, and will tell you how to use those particular tools for solving power system problem. So let's see a list, which is of course a brief list. Unit commitment, a very typical example of optimization wherein we try to allocate this plant load amongst the units so as to minimize the total cost of generation. Load scheduling is an extended version of unit commitment, we can say, wherein we try to allocate the system load amongst the plant. In unit commitment, we try to allocate the plant load amongst the units. And in load scheduling, system load amongst the plants, so that the total cost of generation is minimum. Again, as I said, minimum, it means it is optimization. The difference between, most of you or all of you must be knowing difference between unit commitment and load scheduling. The basic difference, in load scheduling, we have to take into account transmission losses. In unit commitment, we can neglect it. Then the next is overcurrent relay coordination, which can be divided into two parts, and that is why you will find that I have listed it as third and fourth. What you can do is you can find the optimum time multiplier setting considering known and fixed values of plug setting. Or what you can do is you can find out the optimum value of time multiplier setting and optimum value of plug setting also. So overcurrent relay coordination can be taken as a linear problem if you consider that the plug settings are fixed and only time multiplier settings are to be found out. And same overcurrent relay coordination problem can be taken as a non-linear programming problem if you consider that plug setting is also to be optimized. Then, as I said yesterday, determination of optimum value of switching angles of power devices in multi-level inverter. The aim is to minimize the harmonics in the inverter. Many people have worked on this. Transmission line fault location. If time permits, I will be taking this transmission line fault location. This basically is not a problem of optimization, but I have converted it into a problem of optimization and have got very good results. I mean, fault can be located by converting the problem into optimization problem. Sometimes just by looking, it seems that it is not an optimization problem, but then we can convert it by some means or other to optimization problem. But it is not true in all the cases. Every problem will be, we will be able to convert any problem into optimization problem. No, the answer is no, not like that. There are some problems which are to be solved in different ways. They are not optimization problem. Transmission network expansion planning, in which we can again have two categories, static planning and dynamic planning. This is also a topic which is always open for research. Many researchers have worked. You will find n number of papers in IEEE, elsewhere, Taylor Francis and all that on this particular topic. And the still papers are coming. I mean, still people are working on this particular topic. Optimum placement of phasor measurement unit, PMUs. PMUs are getting good attention at present. Why we have to think about optimum placement of PMUs? Because the cost of PMU is very high. So it cannot be placed on every bus. So we have to search for the optimum placement. Where we should locate the PMUs, where we should place the PMUs. There are some problems which after few days becomes obsolete problem. This problem, PMU placement problem, may become an obsolete problem after few years. After few years, if the cost of phasor measurement unit goes down with the advancement in technology, if the cost of PMU goes down, then what will happen? Then every power sector, every say company, transmission company, would like to place PMU on each and every bus if the cost goes down. And then there will be no question of optimum placement. So this problem is currently a problem of research, but after few years, it may not be a problem of research. Then optimum placement and sizing of STATCOM for voltage stability enhancement. STATCOM is a FACTS device. In place of STATCOM, even you can think of some other FACTS device and you for voltage stability enhancement, or you can have two different FACTS devices, three different devices used for voltage stability enhancement, and you can give the comparative analysis of these. You can think of optimum placement and sizing, where the STATCOM should be placed and what should be the rating of that STATCOM, that is size of the STATCOM, which is to be used for voltage stability enhancement. Maximum power point tracking. This is also a topic of interest since long. Those who are working in non-conventional energy area, they must have come across this maximum power point tracking. Reactive power planning, fault section estimation. This comes into picture when the fault is permanent in nature. In case of temporary fault, the fault is cleared by opening and reclosing of circuit breakers. As we know that the circuit breakers opens and recloses 3 times, and then finally, if the fault is permanent, it remains open. So in case of transient faults, in case of temporary fault, transient faults, the faults can be cleared just by opening and reclosing of circuit breaker. We need not even locate the fault. Fault has come and gone. Fault has come, circuit breaker relay sensed the fault, circuit breaker opened, and before reclosing of circuit breaker, fault is cleared, so circuit breaker closed and supply restored. So this particular point, fault section estimation, this comes into picture only in the case of permanent faults, wherein the section is to be estimated, the fault is to be located, because the team has to go personally, physically the team has to visit to the site and say rectify the fault, clear the fault. And as the team has to physically go to the site, so the fault should be located properly, and the location should be accurate, so that the team need not move here and there. I mean, if you look at the fault and say that fault is at a distance of 15 kilometers from this particular bus where I am sitting at present, or this substation, and then the team goes and finds that no, at a distance of 15 kilometers there is no fault, and then they go on searching the fault and they find that fault is somewhere at a distance of 25 kilometers from that substation. That should not happen. Fault has to be located with a great accuracy. So for that you can apply optimization technique, fault section estimation. Load forecasting is another thing wherein you can apply optimization technique, where we forecast the load. It may be short term, short range forecasting, medium range forecasting, and long range forecasting. Long range forecasting is required for a particular thing that is listed in 16th, generation planning optimization, generation expansion optimization. For that you need long range forecasting. So it can be a combination of two problems: first forecasting and then planning the generation expansion. Network configuration for loss reduction, then prioritizing the investments in distribution network, where to invest first, where to invest next, and so on. Then distribution network expansion. So these three sections, expansion of these three sections is going on continuously, and that is a continuous problem of study: generation expansion planning, transmission network expansion planning, and distribution network expansion planning. In all these we can apply optimization. So this is a small list, as I said, very small list of giving only 17 examples. You can quote hundreds of examples in power system engineering wherein optimization is applicable. So what I will do, I will take say three or four tools of optimization as per the time restriction, and then I will try to take say 2-3 applications of optimization to power system engineering, and then we will see in what category that particular problem falls, which tool is to be applied there. So that we will see. Initially, while explaining the tools of optimization for in MATLAB, I'll be taking simple general example. They may not be examples from electrical engineering, just to explain how that tool is to be used. And then afterwards, maybe in the second session today, I'll take few examples from power system engineering out of this list of 17. So let's come to optimization using MATLAB. So far as MATLAB is concerned, those who have worked with MATLAB, they must be having an experience that it seems to be the simplest language across which we have come till now. Very user friendly. You can just write the code, run. If there is any bug, MATLAB will suggest you what is to be done. You can debug it and again run the program. So very interesting. Lot of facilities are available, hundreds and thousands of The functions are available, mathematical functions, optimization functions, control system functions, fuzzy logic, neural network, and whatnot. There are so many tools available, toolboxes available in MATLAB. So once a person starts working with MATLAB, he or she falls in the love of MATLAB and forgets about any other language. That is what has happened with me. I started with computer programming right back in 1986. 1986, I started computer programming and started with Fortran 4. Then I worked with basic programming, turbo basic programming, then C programming, COBOL programming, Pascal programming, Fortran 77, and finally I came in touch with MATLAB, and I found that as compared to any other language which I have used earlier, MATLAB is simple, very user friendly, and very powerful. Very powerful. As we know that it is a matrix laboratory. MATLAB is basically abbreviation of matrix laboratory. Likewise, as I said, parallel free software, open software is Scilab, which stands for Science Laboratory. So MATLAB is a special purpose computer program which is optimized to perform engineering and scientific calculations. And it started life as a program designed to perform mathematics. In the beginning, MATLAB was having very few tools, maybe for solving simultaneous linear equations, for finding the multiplication of matrix, for finding the transpose of matrix, that's all. But over the years, it has grown into a flexible computing system capable of solving essentially any technical problem. And that is why it is called the language of scientists and engineers. It is the combination of many things, and the combination of analysis capability, flexibility, reliability, powerful graphics, and thousands of efficient and accurate built-in functions. That makes MATLAB the main language for engineers. You will very rarely find nowadays an engineer who has not worked with MATLAB, at least an electrical engineer who have not used MATLAB. It is very much possible that some of the people have not used MATLAB programming. They may be using MATLAB Simulink, where the simulation tools, simulation boxes are available. You can simulate the, say, network, a particular system, and you can get the result. Let's come to MATLAB optimization toolbox. As I said that in MATLAB, you have many number of toolboxes available. MATLAB gives you a toolbox for control system problems, fuzzy logic problem, neural network problem. Likewise, it gives a toolbox for optimization problems also. Control system, if you see, in fraction of second, just with a command, you can get root locus of any complicated system. Root locus, Bode plot, everything. Simple, you just have to give a simple command and get Bode plot of system. You can get root locus of the system and decide about the stability of the system. Very powerful tools available. Let's talk about and concentrate on optimization toolbox only, because our STTP is related to optimization. So if you go through the MATLAB optimization toolbox, you will find that there are 23 functions available. I am talking about MATLAB version R 2010. Nowadays, few more tools have been added, and nowadays the genetic algorithm tool, particle optimization tool, and particle swarm optimization tool, and simulated annealing tool, these type of tools have also been introduced and included in the optimization toolbox only. So number of functions, you may find more number of functions now in MATLAB optimization toolbox. Okay, we cannot deal with all the tools in one or two sessions. It can be a separate STTP. MATLAB optimization toolbox can be a separate STTP of 1 week or 2 weeks maybe. So we will concentrate on 2-3 types of problem, 2-3 categories of problem which we have seen. Yesterday we have seen two broad categories, linear and non-linear. In non-linear we have seen two categories, unconstrained and constrained. So we will concentrate on these three functions. LeanProg, which is used to solve linear programming problem. Fmean UNC, which is used to solve non-linear unconstrained optimization problem, and Fmean which is used to solve non-linear constrained optimization problem. So let's begin with a linear problem. LeanProg, LINPROG, that is the command. LeanProg stands for linear programming. It stands for linear programming. Afterwards, if time permit, we will see two more functions, fsolve and f0. Fsolve is used to solve the non-linear simultaneous equations. Many times we come across in our problem simultaneous equations which are non-linear in nature. You may think about the Newton-Raphson method used for load flow analysis. We come across non-linear simultaneous equations. Those non-linear simultaneous equations can be very easily solved using the tool fsolve. Then f0 is a function which is used to find root of an equation. So f0 deals with single equation. It finds the root of equation. I mean one equation, one unknown. To find the root, to find the value of the variable, f0 can be used. And in case of simultaneous equations, non-linear, we use fsolve. So if time permits, we will go for fsolve and f0. Otherwise, we will say concentrate on LeanProg. Then we will go for fmean UNC, and then we will go for fmean con. So let's see LeanProg. As I said that initially, to explain the particular tool of MATLAB, I will be taking simple general example, and then we will proceed for afterwards in the next session. We will take some examples from power system engineering. So let's take LeanProg. There is one basic thing in the MATLAB optimization toolbox which we have to keep in mind always. Rather, I will say two things which we should keep in mind. The first thing that is to be kept in mind is the function, any function which is available as an optimization tool in MATLAB optimization toolbox considers that the function is to be minimized. It considers that the function is to be minimized. We have to be very careful about this. If we come across a situation where we have to maximize, we should first convert the function into minimization type. This is one thing which we have to keep in mind. And the other thing, okay, so this is true for LeanProg, fmean UNC, it is true for fmean con for all. Fmean search, FSE, MINF, whatever you use, it considers that the function is to be minimized. Function is to be minimized. The second thing that you have to keep, see why I am telling you, because what I said that if you have got a tool, you should know how to use that tool. What are the limitations of the tool and how to overcome those limitations? That should be known. So keep in mind that MATLAB function which is used, any MATLAB function which is used to solve an optimization problem considers by default, it considers that the function is to be minimized. If the function is to be maximized, can we not use those tools? No, it is not like that. We can use the tool. अदरवाइज तो उसका ज्यादा यूज ही नहीं होता था बिकॉज देर आर मेनी सिचुएशंस वेर इन वी ट्राई टू मैक्सिमाइज समथिंग तो देन व्हाट इज टू बी डन सिंपल वेरी सिंपल the maximization problem can be easily converted into minimization problem simply by multiplying the function by -1. We will see. I'll take an example of that type also. This is one thing which we have to keep in mind. The other thing which we should keep in mind is that all the inequalities are considered to be of less than equal to type. Inequalities are considered to be less than equal to type. So if you come across a constraint which is of greater than equal to type, you should convert it into less than equal to type. And how we can do this? It is very simple, basic mathematics. If it is an inequality, any inequality, you take any inequality, multiply both sides by -1, you will find that the inequality gets converted into other type. Less than equal to, if you multiply both sides by -1, it becomes greater than equal to. And if it is greater than equal to, multiply both sides by -1, less than equal to. So what I wanted to say focus is that before application of any MATLAB optimization tool, we should first of all convert the objective function into minimization type. Then we should convert all inequalities into less than equal to type. And then only we should proceed for application of the tool. So keep this in mind. Let's proceed. Solving linear programming problems using LeanProg. Solving linear programming problem using LeanProg. LeanProg is a function. It solves linear programming problem. I have already told. Another thing that I have told is this function finds the optimum solution, that is minimum of an linear programming problem. Important. It considers the objective function to be of minimization type, as I said earlier. If the given objective function is of maximization type, it should be converted to minimization type. How it can be converted? Very simple. Let's say that you have a function which is represented by -fx. See the graph of -fx. It is shown by dotted line. The maximum occurs at x is equal to x star. Multiply the objective function by -1. It becomes fx. And the minimum occurs exactly at x is equal to x star. So optimum point remains same. So far as value of function is concerned, you will get the minimum value, multiply that by -1, you will get the maximum value of the original function. So this is how a maximization function can be converted into minimization function just by multiplying the objective function by -1. Also, another thing which should be kept in mind, LeanProg function considers all the inequalities to be of less than or equal to type. See, I am talking about inequalities only. हाँ, equality तो अलग रहेगी, वो कैटेगरी अलग है. Equal to वाली कैटेगरी अलग है. We are talking about inequalities. All the inequalities are considered as less than equal to type. Hence, the inequalities of greater than or equal to type should be converted to less than or equal to type. And as I said yesterday, that in optimization, we never come across less than or we never come across greater than. If it is less than, it will be definitely less than or equal to deciding the boundary. If it is greater than, definitely it will be greater than or equal to. So only less than or only greater than, you will never find in an optimization problem. Okay, so these two things we have to keep in mind. With these two things, we can proceed further for the simplest form of the syntax of leanprog. The syntax of leanprog function in simple form is x comma fval is equal to leanprog fab aeq beq lb ub. We will see the meaning of the terms one by one. There are two things which are appearing on the left hand side, and in computer programming, whatever we write on the left hand side of the equation is actually the output. Right hand side is calculated and the result is stored on whatever we have on left hand side. But here you will find that there are two things. This is a beauty of MATLAB, that you can get multiple outputs. There are two outputs, X and FVAL. What are these two? X indicates, see, if you see this, you will realize that we are interested basically in two things. We are interested in optimum point, that is the value of say design vector, value of design variables, which is giving the optimum solution. That is one thing. And second is, what is the value of objective function at that particular point. So we are interested in the optimum point and the optimum value of objective function. So X contains, finally, after leanprog is being executed, X contains the optimum point. So X contains actually the design vector. X is the output vector which contains the values of variables which gives optimum solution. Values of variables, single or multiple, depending upon whether it is a single variable function or multivariable function. So it gives the values of variables which gives optimum solution. And what other thing that is required is the optimum value of function that is available in FVAL. FVAL is an output variable containing the optimum value of the function, minimum, because leanprog finds minimum. So X is a vector and FVAL is a scalar quantity. How many elements will be there in X vector depends upon how many design variables are there. If there are two variables, there will be two values. If there is one variable, there will be only one value, and so on. This X and FVAL, they are representative terms in place. It is not necessary that you must use these representations only. I can say on left hand side, I can say A comma B, or say X comma Y. I am having B and A on right hand side, so I will not use AB. I can say P comma Q. If I say P comma Q, P will be the output vector which will contain the values of variables which gives optimum solution, and Q will be the output variable that will contain the optimum value of function. So these are just symbolic representation. You can use different variables for this. Similar is the situation with the variables which have been used on right hand side. Symbolic representation है, उसकी जगह पे आप दूसरे variables use कर सकते हैं. So now let's come to the things which we have on right hand side and try to understand the meaning of each term, and then we will proceed for taking a problem using leanprog. F is a vector that contains the coefficients of variables in the objective function. If my objective function is 3x1 plus 4x2 minus 3y2, so F will be a vector which will contain 3, 4, minus 3. 3x1 plus 4x2 minus 3x3. That is my objective function. So F will be a vector that will contain the coefficients, means 3, 4, minus 3. That is F. Coefficient of variables in the objective function. A is a matrix, each row of which contains the coefficients of variables in the inequality constraint. That is, this capital A takes care of left-hand side of inequality constraints. Left-hand side of inequality constraints. Then B is a vector whose elements are right-hand side of inequality constraints. So A and B. A is a matrix, B is a vector. A is a matrix, B is a vector. A contains the left hand side of A takes care of left hand side of the constraints, and B takes care of right hand side of the constraint. Inequality constraint. And I repeat that before using the function, all the inequalities must be converted into less than equal to type. नहीं तो आपका आंसर गलत आएगा. You will get wrong result. So be careful about that. Whatever is A and B representing for inequality constraint, same things are taken care of or represented by AEQ and BEQ for equality constraint. So AEQ is a matrix which takes care of left hand side of equality constraint. Takes care of left hand side of equality constraints. And BEQ, so AEQ is a matrix in which we write the coefficient of variables in the equality constraints. First row is formed by first equality constraint, second row by second equality constraint, third row by third equality constraint, and so on. Likewise, BEQ is a vector. Very much parallel to AB, we have AEQ, BEQ. AB take care of inequality constraint, AEQ, BEQ take care of equality constraint. That's all. उतना ही difference है. So BEQ is a vector whose elements are right hand side of equality constraints. LB is a vector of lower bounds, lower limits of variables. Say if we have x1, x2, x3 greater than equal to 0. So then what we say? x1, x2, x3 greater than equal to 0. It means that the lower limit of x1, x2 and x3 is 0. So LB representing lower bound. LB indicates lower bound. UB indicates upper bound. If you have upper bound given for the variables, that x1 should be less than or equal to 26, x2 should be less than or equal to 105, and x3 should be less than or equal to 37.49. Then these values are written in the form of a vector, and that vector is called UB. That vector is called UB. So these are the meaning of the things which we have on the right hand side. Actually, this would have been more effective. I mean, session or this particular part would have been more effective had we been having a chance to interact offline. I am telling something and you are doing the same thing simultaneously with MATLAB using PCs or laptops. That would have been more effective. But anyway, because of the situation, nowadays we are going for online. Doesn't matter. Let's continue. So we have seen the meaning of terms. Those are there on the left hand side, and meaning of terms, those are there on the right hand side. Now let's see a problem, how to apply this lean prog function to find the solution of the problem. I'll take two problems in case of lean prog, and after that I'll be taking one problem each for F mean UNC, unconstrained nonlinear minimization, and F mean con, that is constrained nonlinear minimization. So let's take lean prog and try to solve a linear programming problem. Say that this is a problem, find xy so as to maximize 2x plus 6y subject to the constraint x minus y greater than equal to minus 1 and 2x plus y less than or equal to 2. And the design variables x and y are following the non-negativity constraint. So x and y both should be greater than or equal to 0. This is a problem. Initially, I have taken a simple problem having two variables and two constraints only. But with lean prog, you can solve a problem with n number of variables and m number of constraints. You can have combination of inequality and equality constraint. There are say 6 variables, 5 inequality constraints and 7 equality constraint. You can get the solution in fraction of seconds. Only thing is you just have to put, or you just have to feed all the things in proper format, and then you will get the solution. You need not know any method, you need not apply any method. So powerful tools we have in MATLAB optimization toolbox. Okay, let's see how to solve this particular problem. As I said that before proceeding, actually I should write the function as minimize z is equal to minus 2x minus 6y. Minimize z is equal to minus 2x minus 6y because that is the requirement. पहला मुझे काम क्या करना है, that I should write the objective function in minimization form. See, as this is some sort of hands-on, I have to explain the tools, so I am proceeding little bit slow. If you feel that I am going very slow, you can just tell me, I'll increase the speed by some amount. Okay, so what I should do, first of all, I should convert the objective function into minimization type. I should say, and once I convert it into minimization, I will not call it as f because f is 2x plus 6y. So minus 2x minus 6y cannot be f again. I'll use some other representation. Let's say z. Z is equal to minus 2x minus 6y and subject to the second thing that I have to be careful before using lean prog is I should have all inequalities. If I do not have any inequality, there is no problem. If I have only equalities, no problem. Inequalities agar hai, so they must be converted into less than equal to type. So for a second, and remember one thing, that the inequality which is written at the bottom is actually representing non-negativity constraint. Usko convert nahi karna hai. That is x, y greater than equal to 0, which means that x greater than equal to 0 and y greater than equal to 0. That is non-negativity constraint. It will be taken care of by lower bound. It will be taken care of by lower bound. It is not to be converted into less than equal to type. Okay. Second constraint, fine, it is already less than equal to type, but the first constraint is to be converted into less than equal to type. How to convert? Basic mathematics, multiply both sides of inequality by minus 1. The nature of inequality changes. So I can write first constraint as minus x plus y less than equal to 1. So see, I have made the changes. This was the problem given. You just observe the objective function and you just observe the first constraint. You will find that I have made the change. Now I am calling the function as z, which is minus 2x minus 6y. Constraints minus x plus y less than equal to 1, 2x plus y less than equal to 2, and you can see that xy greater than equal to 0 is not changed. It is still as it is. Okay, with this now we will proceed for applying lean-prog function. This problem can be very easily solved using graphical method, using simplex method, or you can use any other method which was listed yesterday. But we will see that how it can be very easily solved using the lean-prog function without knowing any method. Let's see the MATLAB code. Very simple and small. CLC, which is used to clear the command window. Clear all, which is used to clear all the variables in memory. If there is something already stored in some variable, that will be cleared. पहले कोई प्रोग्राम रन किया था, उसके वजह से there is something available in A, something available in B. That should not disturb our problem, our solution. So clear all means clear everything that is there in memory. I mean, all the variables are cleared. They are reset. Then we will define the things which we have on right hand side. What we have on right hand side, lean-prog, and then within parenthesis what we have to write, F, A, B, AEQ, BEQ, LB, UB. So we will now see what are these things. What is F? F is the coefficient vector containing the coefficient of variables in the objective function. I have changed the objective function in minimization type as minus 2x minus 6y. I am displaying the complete problem just for reference. So minus 2 is the coefficient of x and minus 6 is the coefficient of y in the objective function. So I have formed a vector f having minus 2, minus 6. They are separated by a space. They can be separated by a comma also. Now talking about A. A is a matrix that takes care of left hand side of inequality constraint. So first inequality constraint, the coefficients are minus 1 and 1. So the first row of A, you can see here, the first row of A is containing minus 1 and 1. Second row of A will contain 2 and 1. The second row contains 2 and 1. And as they are rows, they are to be separated by semicolon. They cannot be separated by comma. Two rows, those who have used MATLAB, they must be knowing all these basic things, preliminary things, that the rows are to be separated by semicolon. So second constraint, left hand side 2, 1. Now we will write the right hand side of inequality constraint, B. And each has to be written, it is a column vector. So each right hand side is to be written in a separate row. 1 semicolon 2, 1 comma 2 लिखा तो वहां एरर आ जाएगी, आपको आंसर नहीं मिलेगा. So 1 semicolon 2, 2 rows. Because matrix A is having 2 rows, so vector B should have 2 rows. Okay, then next comes AEQ, BEQ, which take care of the right hand side of the inequality constraint. AEQ, BEQ, which take care of equality constraint, left hand side and right hand side respectively. In this particular problem, we do not have any equality constraint. As we do not have any equality constraint, so AEQ and BEQ will be simply replaced by bracket open, bracket close. I will show you. Lower bound, the last one, x, y greater than equal to 0, indicates that the lower bound of x is 0, the lower bound of y is also 0. So LB, lower bound, is written as 0 space 0 or 0 comma 0. And then the next, apply leanprog. X comma FPAL is equal to leanprog F comma A comma B. You can see in place of AEQ and BEQ. क्या करना है अपने को? Bracket open close, and then LB. UB I have not written because upper bound is not given. Upper bound is not given, so I have not written UB. Now one can think about, as upper bound is not given, so I am not using UB. Similarly, as the equality constants are not there, why should I use bracket open close? उसको भी छोड़ देंगे. Equality constant नहीं दिया है, उसको छोड़ देंगे. But no, syntax gives you the particular sequence. If you want to use the lower bound, if lower bound is given and you want to use that lower bound, उसका position fix है. Lower bound position is fixed, and hence whatever is there as per syntax, whatever is there towards the left hand side of lower bound, that must be defined. उसके बाद ही लोअर बाउंड आएगा, तब तक लोअर बाउंड नहीं आ सकता है. Okay, just consider that there is no lower bound. Had there been no lower bound, then we would have said there is no upper bound, there is no lower bound. Hence, what we would have said, leanprog F comma A comma B. That's all. Parenthesis close. Because now lower bound is not there. So if there is no lower bound, I need not specify AEQ, BEQ also. Why I have specified AEQ and BEQ by bracket open close, even though there is no equality constraint, is that if I want to use lower bound, as per syntax, whatever is there before lower bound must be defined, must be specified. Okay, so that has to be defined. And I repeat, had there been no lower bound, we know that there is no equality constant also, we would have simply terminated our parenthesis after small b. Leanprog F comma A comma B. That's all. Finish. ठीक है, यहाँ लोअर बाउंड है, इसलिए हमें AEQ BEQ फॉर्मेलिटी है वो पूरा करना ही पड़ेगा, तभी अपन लोअर बाउंड तक जा सकते हैं. Okay, so this is how I have written MATLAB code. Very simple, just a 3-4 lines program, and you will get the result. So just enter this in MATLAB and run this program. You will get the result. यहाँ result नहीं दिखाया है. I will take another problem. दूसरे problem का मैं result भी दिखाऊंगा आपको. ठीक है? So let's take this problem. Yesterday I have shown this problem as a problem or application of optimization in the field of agriculture. The problem is formulated like this. Find x1, x2, x3. What x1, x2, x3 are representing? They are representing the area or acres of land. Those should be allocated to corn, wheat and soyabeans respectively. Corn, wheat and soyabeans respectively. So find x1, x2, x3 so as to maximize. The profit is to be maximized, and that is 30x1 plus 40x2 plus 20x3. Maximize 30x1 plus 40x2 plus 20x3 subject to the constraints. Now we need not, I will not spend the time in explaining the formulation. Yesterday I have explained how the problem can be formulated. Like in the same way you can formulate this problem. It becomes 100x1 plus 120x2 plus 70x3 less than equal to 1 lakh. Because farmer can spend 1 lakh rupees on preparation of land. Similarly, the farmer has 8,000 man days. Less than equal to क्यों रखा है? Farmer, see, while formulating the problem, there are few things which we should take carefully. The problem says that the farmer has 1 lakh rupees for preparation. 1 lakh rupees for preparation. So one can think that the constraint should be 100x1 plus 120x2 plus 70x3 is equal to 1 lakh. Whereas what I have written is 100x1 plus 120x2 plus 70x3 less than equal to 1 lakh. Why? Because of simple logic. Because of simple logic. If I say that you have got 1 lakh rupees for, say, fitting tiles in your drawing room, does it mean that you should spend entire 1 lakh rupees? आपको आपके घर के ड्राइंग रूम में टाइल्स लगाने के लिए 1 लाख रुपए दिए हैं, दिए मतलब आपने निकाल के रखे हैं, nobody will give you, आपको घर के टाइल्स खुद को ही बदलना है, तो if required of course, तो आपने डिसाइड किया that I can spend 1 lakh rupees for changing the tiles of my drawing room. What you will think? Will you think that I have 1 lakh rupees, so I should spend entire 1 lakh rupees? खर्चा तो करना ही चाहिए मैंने पूरा 1 लाख रुपए. No, what you will think that if the work can be done in 80,000, it is well and good. I will save 20,000. I will use those 20,000 rupees somewhere else. So you will try to minimize that amount as less as possible. So you will not say that the expenditure to be made should be exactly equal to 1 lakh rupees. No, if you can do it in less than that amount, it is well and good, fine. So less than equal to 1 lakh. Likewise, man days also, because for every man day, the farmer has to pay. What is man day? Number of workers multiplied by number of days for which the laborers are working. If the farmer can get the work done by less number of workers in less number of days, the farmer will be saving the salary amount to be given to the laborers. So definitely less than equal to 8,000. Then the farmer has 1,000 acres of land. So x1 plus x2 plus x3 should be equal to less than equal to 1,000. I will make this thing clear afterwards. ये प्रॉब्लम सॉल्व करने के बाद बताऊंगा कि why equal to symbol is not used here. I'll make it clear. Okay. And I cannot allocate any negative land area to any particular crop. So x1, x2, x3 greater than equal to 0. Lower bound. Let's proceed. This is the MATLAB code and this is the problem statement. You can just see. You can just have a look on the vector f. It is not 30, 40, 20. What it is? Minus 30, minus 40 and minus 20. Why? Because I will be using leanprog, and leanprog considers the function to be of minimization type. So I must write the function as minimize f is equal to maximize z hai, so I can say minimize f is equal to minus 30x1 minus 40x2 minus 20x3. That is why minus 30 minus 40 minus 20. Then there are three inequality constraints. As there are three inequality constraints, matrix A will contain 3 rows and the row elements will be 100, 120, 70. Then semicolon, second row, 7, 10, 8. I am picking up the values from here, 100, 120, 70. 7, 10, 8. And the third constraint is x1 plus x2 plus x3 less than equal to 1,000. So 1, 1, 1. This is third row. You can see here, this is third row. Now I will talk about the right hand side of inequality constraint. First, of course, first I have checked whether all the inequality constraints are less than equal to type or not. I got answer yes, and then only I have proceeded. Okay. So the right hand side, each element is to be written as a row. So 1 lakh, semicolon 8,000, semicolon 1,000. Vector B. We do not have any equality constraint at present, but lower bound is there. x1, x2, x3 greater than equal to 0. So lower bound is there. as lower bound is there, we will specify like this: x comma FVAL is equal to ln prog FAB. In place of AEQ, I am saying bracket open close. In place of BEQ, I am saying bracket open close, and then LB, lower bound, which is specified here as 000. Lower bound 000. When I run this program, I get this answer: x is equal to 250, 625, 0. As I said that x is a output vector which contains the values of design variables. At present, it is containing 3 values because there are 3 design variables: x1, x2, x3. So what the solution is suggesting, that I should allocate 250 acres for corn, 625 acres for wheat, and I should not allocate any amount of land for soya beans. Only corn and wheat, 250 and 625 acres, giving me the function value FVAL is equal to minus 3.2500 E plus 04. E plus 04 indicates multiplied by 10 raised to power 4. Multiplied by 10 raised to power 4. So actually FVAL means minus 32,500. Minus 32,500. Now, while writing the final answer, we have to be very careful, because actually the function was a function which is to be maximized. We have converted it into minimization type. We converted it into minimization type. So the minimum value is coming out to be minus 32,500. Actually, the maximum value of original function, given function jo tha, given function, the original function will have maximum value negative of whatever result I have got. While presenting the final answer, again, be careful. Be careful. Don't say that profit is equal to minus 32,500. No, it is 32,500. Profit, it was Z to be maximized. We converted it to be F, which is to be minimized. So maximum profit is positive 32,500. How much land is utilized? Is 250 plus 625. That is 875 acres. Now, one can think that 125 acres land is remaining idle. 125 एकड़ लैंड में मैं कुछ नहीं कर रहा हूं, सो आई एम एट लॉस. इतनी बड़ी जमीन खाली पड़ी है, उस पर मैंने कुछ भी नहीं किया, मुझे लॉस हुआ. सो नो, इट इज नॉट लाइक दैट. लेट्स सॉल्व द प्रॉब्लम इन अदर वे. सी, I have made a very small change. Let's have a look at the third constraint. Now I am saying that I will be utilizing entire land of 1000 acres. Instead of x1 plus x2 plus x3 less than equal to 1000, I am now saying x1 plus x2 plus x3 is equal to 1000. Is equal to 1000. Okay. So when I am saying x1 plus x2 plus x3 is equal to 1000, I am trying to utilize entire amount of land. But remember that it is not that I will get the profit only. The moment I say I have to use entire land of 1000 acres, I will have to spend amount on preparation of entire land, and I will have to spend amount of man days of work which will be utilized for the entire land. For this, let's see what is changed. This will give you an idea that if equality constraint comes, what is to be done. वो भी इसमें आपको समझ जाएगा. First, you can see that the objective function is not having f is equal to 30, 40, 20. It is minus 30, minus 40, minus 20. Now, there are only two inequality constraints. Now, only two inequality constraints. So, A will have two rows only, 100, 120, 70 and 7, 10, 8. These are the two rows. Likewise, vector B will also contain only two values written in two different rows as 1 lakh semicolon 8000. Now the third constraint is equality constraint. थर्ड इज एन इक्वलिटी कंस्ट्रेंट. सो अभी ए क्यू बी क्यू के जगह पे ब्रैकेट ओपन क्लोज नहीं रखना है बिकॉज वी आर हैविंग इक्वलिटी कंस्ट्रेंट. So I will define the left hand side of equality constraint with the help of a matrix AEQ 1 1 1. Right hand side 1000. Had there been two equality constraint, AEQ would have got two rows and BEQ would also have got two rows. अभी एक ही कंस्टेंट है तो एक रो आ गया. लोअर बाउंड 0 0 0. Now instead of FAB bracket open close, I am writing AEQ BEQ because now I have defined them, and then LB. When I run this program, what I get is 545 acres to corn, 272.72 acres to wheat, and 181.81 acres to soybeans, giving a total of 1000 acres. The land utilized is 1000 acres. Function value is 3.0909, sorry, minus 3.0909 into 10 raised to power 4. But actually it is negative of the function, so actual profit is 30,909. 30,909. Let's have a look. What was the profit earlier? It was 32,500. And how much was the land utilized at that time? It was 875 acres. So this will make it clear if we are having a doubt in mind that why I am not utilizing 1000. It is not only the profit that you will earn, you have to spend amount also. ज़्यादा land use करेंगे तो आपको खर्चा भी ज़्यादा करना पड़ेगा. And that it is suggested in this particular problem that it is better to use less land. Okay. Now, this is a small problem. I'll take very fast just to show you that it is not necessary that you should write MATLAB code. You just go to the, say, prompt, command prompt, which is greater than. On the command prompt, you just write Optim tool, OPTIMTOOL, continuous, and press enter. The moment you press enter, you will come across this screen. By default, the solver is taken as constrained nonlinear minimization, but you want to use linproc, so you just go here, click, you will find the list of the functions available. linproc अभी नहीं दिख रहा है क्योंकि वो L से शुरू होता है तो अल्फाबेटिकली अरेंज किए हुए है. You just click here and you will find that linproc is available. So just click on this and you will find that linear programming appears over here. Write the function here, objective function, coefficient of variables in the objective function, -4, -3, -6. Then see the constraints. You have left hand side of inequalities, right hand side. Then for equalities, left hand side, right hand side, then lower bound and upper bound. Just go on writing the matrices and vectors. This is left hand side of inequality constraints, right hand side of inequality constraints. अभी जो प्रॉब्लम डिस्प्ले किया था मैंने जस्ट पहले. Then equality constraint. There is no equality constraint in the problem. Right hand side bracket, just a left hand side bracket open close, right hand side bracket open close. Lower bound 0 0 0. There are three variables. Upper bound, there is no upper bound, so we have not defined upper bound. We have defined everything. I will just press start. ये start button है इधर. Run solver and few results. So if you are using this GUI, this is called GUI. If you are using this GUI, you need not write anything. You need not write any line of the program. Simply put the values over here and say start. When you say start, it will run and you will find the results here. Optimization running, objective function value minus 1066.66, optimization terminated. Means you have got the value. This is the value of objective function. And what about the values of variables? You can see here final point. So this is x1, x2, x3, and the value of x1 is 0, value of x2 is 42.222, and value of x3 is 156.6667. So this is how you can use GUI also instead of writing the program. GUI भी use कर सकते हैं. You can just clear the result when you want to go for some other problem or you want to run the same problem again. You can just click here. यहाँ पे देखेंगे clear result लिखा है. You click this button and the result will be clear. You will not get any output here, any output here. You can run some other problem. You can solve some other problem. Change this, and you will get the other problem. Now we have say a few time, 5-10 minutes. I'll just at least try to cover one more tool. Solving unconstrained nonlinear optimization problems using MATLAB. We have seen how to solve a linear optimization problem. Now we will see how to solve a nonlinear optimization problem using MATLAB. So let's proceed. Nonlinear unconstrained nonlinear optimization problem. This is a problem. Yesterday, while formulating the problem, we have seen that it is an unconstrained nonlinear optimization problem. For this type of problem, the function that is to be used is fmean UNC. Sorry, fmean UNC. F is for function, MIN is for minimization, UNC stands unconstrained, UN un and C for constraint. Unconstrained minimization. Unconstrained minimization. Fmean UNC. And remember that whenever you are using these functions, you have to write them in small letters only. Don't use capital letters. That will not be accepted. There will be syntax error. MATLAB is a case sensitive language. MATLAB is a case sensitive language. It finds the minimum of an unconstrained multivariable function. Unconstrained multivariable function. And this thing is true, as I have said, that this is true for any MATLAB optimization tool. So it is true for this function also, that it considers the objective function to be of minimization type. If the given objective function is of maximization type, it should be converted to minimization type. Same syntax in simplest form. लीन प्रॉग का भी जो मैंने बताया वो सिंपलेस्ट फॉर्म में था, उसमें और एडिशनल फीचर्स है. देयर आर मेनी मोर एडिशनल फीचर्स. देयर आर फ्यू एडिशनल फीचर्स अवेलेबल. Likewise in fmean UNC also, what I am showing is the simplest form of the syntax. There are some additional features. You can go through the help, or you can go through the library and you can read about that. X comma FVL is equal to fmean UNC FUN comma X0. Let's see the meaning of the terms. I think there is, I think I did not explain what is there on left hand side. It is very much similar, very much parallel to what we have seen in case of linprog. X is the output vector which contains the values of variables which gives optimum solution, and FVAL is the output variable that contains the optimum value of function. That contains the optimum value of function. So far as things on right hand side is concerned, there are two things, FUN and X0. Let's see the meaning of the terms FUN and X0. FUN is the function to be minimized. You have a function. So FUN is a function that accepts a vector x and returns a scalar f. The objective function evaluated at x. The function fun can be specified as a function handle for an M file function, MATLAB file function. So basically, you have to write a function subprogram in MATLAB. एंड इसमें भी घबराने की जरूरत नहीं है. इट विल बी ए जस्ट 3 लाइंस प्रोग्राम. 3 लाइन का प्रोग्राम होता है ये FUN. Only thing that we have to keep in mind is that the function is to be written separately. In case of leanprog, if you are saying that it is a 3 variable problem, you will simply have to specify 3 values. But when it is a non-linear problem, and even if it is a 2 variable problem, it cannot be specified directly. It is to be written separately, because 2 variable non-linear problem, the function may be x1 into x2, the function may be 2x1 square plus x2 square, or the function may be x1 plus log of x2, or so on. So the function has to be specified, is to be written in a separate file, and x0, I will show you how it is to be written. And that is why I said that it would have been more effective had we been having an offline course. Anyway, x0 is the initial point. You have to give the starting point. The function starts at the point x0 and attempts to find a minimum x of the function desirable. So you have to give starting point. If you do not know, if you do not have any idea of starting point to be given, it can be given as 0, 0. If it is a 3 variable function, it can be given as 0, 0, 0, and like that. Let's take this problem. It is a single variable problem. X square log to the base e 1 upon x. See how it will be solved, how it is to be solved using f mean UNC. Again, keep in mind that, of course, there is no constraint. So there is no question of any inequality. It is an unconstrained optimization problem. But keep in mind that our aim is to achieve the greatest speed of signaling. We have to achieve the greatest speed of signaling. Achieving greatest speed of signaling means we will try to maximize x square log to the base e 1 by x. We will try to maximize x square log to the base e 1 by x. But if I directly write the function like this only, x into log to ln 1 upon x, it will be treated by default. MATLAB will treat it as a minimization type function. So I should be careful. I should convert it first into minimization type, and then we shall proceed further for applying the tool. So the problem is find x so as to maximize z is equal to x square log to the base e 1 by x. What I should do first? I should say that I have to minimize minus x square log to the base e 1 upon x. I have to minimize this because I want to use MATLAB tool, and the tool which is available, fmean UNC, considers that the objective function is of minima. मैं जो भी objective function डालूंगा उसमें, it will consider it to be of minimization type. So I have to be careful. I have converted the objective function into minimization type, minus x square log to the base e 1 upon x. The program will be very small, but remember that leanprog में आपको एक ही फाइल लिखना पड़ता है. यहाँ आपको 2 फाइल बनाना पड़ेगा. One will be main program, other will be a function which will contain the objective function. Leanprog requires only 1 file to be written. fmean UNC requires 2 files to be written, and fmean con, इसके बाद जो पढ़ेंगे fmean con, constrained non-linear optimization, we have to write 3 files. So at present, let's concentrate on fmean unc. We have to write two files. First file is main file. I'm writing CLC, that is clear the command window, clear the variables, and initialize the vector. x0 लगता है, right hand side में देना पड़ता है. It is a vector, as our objective function is a single variable function. So in place of vector, I am simply saying 0. Had it been two variable function, I would have defined x0 as a vector 0 0 0 0 ऐसा देते थे. And then I'll directly write x comma fval is equal to fmean unc at the rate panther. At the rate जो उधर बोला था कि it is specified by a function handler, so that at the rate is called function handler. You will have to write that at the rate. And panther, I have given the name to the function wherein I will be writing the objective function. I have decided the name. That panther is the name of the function. And then x0 as per the syntax, function with function handler and the value of initial value to be given, that is x0. That's all. This is main program. Main program में इतना ही लिखना है और आपको main program run करना है. But before running main program, if you will write this and try to run, you will not get any output. You will get error that the function panther is not defined. Function panther is not defined. So you will have to write the function. Let's write the function. Function is like this. So now I will write the function. Function file will also contain only 3 lines. The first line is function f is equal to panther x. As I have decided the function name to be panther, I have to use the same name over here. And the function is to be saved with the same name. panther.m से ही इसको सेव करना पड़ेगा, दूसरे नाम से सेव किया तो नहीं चलेगा. Here I am defining the function f is equal to minus x square, minus x into log 1 upon x. log is a function is in MATLAB which finds log to the base e. आपको log to the base 10 चाहिए तो log 10 is the function. Okay, that's all. This is only the thing which is to be defined in the function. So end of the function. Only 3 lines are sufficient. So in main file, you just have to write 3-4 lines. In function also, you have to write 3 lines only. You can see a view. I have taken the screenshots and have made you available. The upper screenshot is giving you the main program. First is what is appearing in green is a comment. Then CLC clear all. x1 is equal to 1. I am starting from 1. उधर 0 लिखा था, यहाँ 1 से शुरू कर रहा हूँ. Doesn't matter. This is initial choice. x comma fval is equal to fmean unc at the rate panther x0. And then I opened another m file. I have named the new file as panther. Because function name अगर panther है तो file name panther.m ही होना पड़ेगा, रखना पड़ेगा. You can see the screenshot of the function. Whatever I have shown in earlier slide, function f is equal to panther x, then f is equal to minus x into log of 1 upon x. End. Function is over. When you run this, so after writing the function, save the function. After saving the function, go back to the main program and run the main program. Don't try to run the function. Run the main program. Run the main program and you will get this result. Here you will find that you are getting single value of x because there is only one variable and it is 0.6065. Function value is coming out to be minus 0.1839. But while displaying the result, what we will say that the result is x is equal to 0.6065. It's okay. But Zmax is not minus 0.1839, but it is 0.1839 positive because I have changed the objective function type. Original objective function by putting x is equal to 0.6065 will give me positive 0.1839. So this is how we can use the function f mean UNC, which is used to solve unconstrained nonlinear optimization problem. So now, before proceeding further, I would like to give you a caution. It is said that do not overfill brain. Allow 1 hour for knowledge to soak in before topping up. टॉप अप करने के पहले आपने जो कुछ भी पढ़ाया, जो कुछ भी बताया, उसका दिमाग में बैठना चाहिए. एंड फॉर दैट allow 1 hour. So let's have a break for 1 hour and we will start with the next session at 11:30. Thank you.
Thank you, sir. If participants have any queries, then they can ask.
Okay, participants can ask their query either in this session or they can ask queries in the next session also. No problem.
Professor Bedekar. Hello.
हाँ, hello
Hello.
sir, बोलिए.
Professor Bedekar, that was a very good presentation. Uh, very informative.
Sir,
Thank
I
you
am
very much.
unable to hear to you, listen to you. आवाज आपकी नहीं आ रही है क्लियर.
Okay, now is it okay? Is it okay now?
हाँ, it's okay. Okay.
Okay, that was a very good presentation, very basic, very informative. Thank you very much.
Thank
I'll
you,
be
sir.
I'm one of the speakers next week. So I was attending to get the idea of what all you cover. So in the list of problems that you said in electrical engineering, I did not find the economic dispatch or that something like that, problems of that type. Is it because that is not your area?
Pardon, sir, I'm not getting what you want to say that I should have taken some problem from electrical engineering for explanation.
No, 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 no. That list you showed, that was very useful.
Uh-huh.
But economic dispatch, load dispatch problem was not there.
So as I said that it is a small list. I mean, you can have hundreds of functions. Economic load dispatch is also one of them. Definitely, it is a application of optimization. Definitely, sir.
Thank you, thank you.
Okay, thank you, sir. Sonali, madam, you wanted to ask something?
Okay, if I can ask another question,
Yes, sure, sir.
why I also teach engineering optimization here at Vellore Institute of Technology. By the way, I think you came here, but I didn't get a chance to meet you. This question is, in electrical engineering, mostly we have only non-linear problems, is it not? Where do we get linear programming problems? As compared to non-linear problems, the applications of linear programming are much lesser, is it not?
Yes. Definitely. The linear programming problems are less so far as electrical engineering is concerned, or even in general, linear problems are very less. But there are some problems which are linear in nature. As I said, that overcurrent relay coordination, I'll be taking it in the next session. Overcurrent relay coordination. If you think about only finding the optimum values of time multiplier setting, considering that the plug settings are known and they are fixed, they are constant, then the problem becomes a linear programming problem. Okay. Similarly, optimum PMU placement problem, it can be divided into two parts. Initially, when you find out how many PMUs are required, that can be stated as a linear programming problem. So there are few cases, even in electrical engineering, wherein the problem can be stated as a linear programming problem. But very true, I agree with you that majority of the problems in electrical engineering, those who are optimization problem, majority of the optimization problems are non-linear in nature. Yes.
Thank you. Thank you very much for that clarification.
Thank you, sir.
Hello. Sir, I have one question.
Ah,
Uh,
yes.
when we use the optimization tools for linear and non-linear programming problem,
Ah.
if I have to apply a particular method of linear programming problem, then how to apply that method? Like in linear programming, various methods are given, simplex, dual simplex, like that.
So depending upon the situation, see, every method have got some limitation. There are some restrictions, and those if you study that particular method, you will come to know that what are the restrictions of that particular method. And if your problem doesn't fit for that particular method, you will have to search for some other method. I mean, if you find that your problem is not fitting into as a problem to be solved by simplex method, you may think of going for big M simplex method or dual simplex method. So method is to be selected depending upon our type of problem and the limitation of the method. So
Similarly
you
for
have,
non-linear programming also.
same. Similarly for non-linear programming also. For non-linear also. Yes.
Okay, sir. Thank you.
Okay, but then when you think of applying some method, you will have to go through the method, details of the method. What
Okay.
I focused today, of course, your question is good, but what I focused today is without knowing the method, formulate the problem and get the solution using MATLAB. That was the focus in today's talk. But
Yes.
yes, if you want to study the method and solve it using some method in detail, you will have to know, you should know the detail, procedure, and the limitation of each method.
Yes, sir. Thank you, sir. Thank you.
Okay, thank you, madam.
So I think there is no queries. So all the participants are requested to join the second session at 11:30 a.m. sharp. So Dr. P.P. Bedekar sir is going to continue the second session. So thank you.
Okay, thank you, madam. I'll be there at 11:30. Thank you.
Yes, sir. Yes, sir. Thank you, sir.
Good morning to all. Kindly note that next session it is going to be started from 11:30. Okay, so you may join sharp 11:30 a.m. Am I audible? Hello. Next session it is on 11:30.
Okay, ma'am. Thank you, ma'am.
ஹலோ, சொல்லுங்க கணேஷன். இன்னைக்கு உங்களுக்கு டியூட்டியா இல்ல அவர் வெங்கடேஷ்கா? டியூஸ்டே ஃப்ரைடேவா உங்களுக்கு? சரி சரி, ஓகே ஓகே ஓகே, தேங்க்யூ. ஆ, ஹலோ. நான் ரகு பேசுறேன். இன்னைக்கு எக்ஸாம் இருக்குதுல்ல, அது நீங்க கொஞ்சம் சீக்கிரம் வந்துருங்க. குட் மார்னிங். இங்கே இருக்கிறீங்களா? இல்ல, வேணாம் வேண்டாம், நீங்க ஒரு 1/2 மணி நேரம் சீக்கிரம் வந்துருங்க லேப்க்கு. லஞ்ச் எங்க சாப்பிடுறதுக்கு போறீங்க? லேப்ல தான் சாப்பிட்றீங்களா? ஆ சரி. எதுக்கும் ஒரு 1/2 அன் ஹவர் முன்னால ரெடியா இருங்க. அந்த பேப்பர் இருக்கிற கொஸ்டின் பேப்பர்ல பட்டணும். ஆ சரி. இல்ல இல்ல இன்னும் ரெடியா இல்ல. 1:30 மணிக்கு நான் வந்து குடுக்குறேன். ஓகே. ஆ ஓகே. சரி.